Even functions and odd functions, part 2. Choose the correct answer from the given ones. The even function from the functions that are defined by the following rules is x power 3, x cosine x, x or sine x, or x sine x. Solution. With respect to f of x equals x power 3, we have the power here is odd, so the function is odd function, and also sine x is an odd function. Here we have the product of two functions. The first is odd and the other is even, so the result will be odd function. Here we have two functions, both of them are odd functions, so the product is even function. So the right solution is letter D. But we must know how to prove it in steps. Okay, let f of x equals x sine x. So the domain equals R, set of real numbers. The domain of the product of these two functions, we have x, its domain is R, and also the domain of sine x is R, set of real numbers. And for every negative x and x belongs to the domain, we have f of negative x equals, substituting x equals negative x in the main function here, substituting x equals negative x, so it is equal, instead of x we write negative x multiply sine negative x, and to complete we have here negative x multiply sine negative x equals negative sine x, and the result equals negative multiply negative is positive x sine x, which equal f of x. Now you can say that since f of negative x equals f of x, so the function f is an even function, and here is our choice. Question number 2. The odd function from the functions that are defined by the following rules is, here we ask about the question about the odd function. Here the first function is x square and it is even function, and the other is odd, so the product is an odd function. So it's clear that is the solution, so our choice will be letter A. Here we have tan x square, it is even function, even, here it is constant function, is even function. F of x equals f of negative x, f of x here equals 1, also f of negative x equals 1, so since f of negative x equals f of x, so the function is even. But here the required is odd function. Let us prove it in steps. solution. We have f of x equals x square sine x. We must write the domain and we must know it. The domain of f equals f of x here is r. Why? Because the domain of the first function is r and the domain of second also is r. We have no roots, we have no fractions, so the domain is r. Okay, now for every negative x and x belongs to the domain r, we have f of negative x equals, substitute x equals negative x, so we have negative x square multiply sine negative x, which equal x square multiply negative sine x, which equal negative. Here we have a positive sign. Positive multiply negative is negative. X square sine x, which equal negative. Here, what about this? This is f of x itself, negative f of x. So according the definition, we have f of negative x equals negative. So the function f is odd function. If f is an even function, and the 2 belongs domain of f, then f of 2 plus f of negative 2 equals 0, 4, 2, or 2f2. Since f is even, function, so f of negative 2 equals f of 2 according to the definition we studied in the previous lessons. Okay, so f of negative 2 equals f of 2 because it is even. So f of 2 plus f of negative 2 equals f of 2 plus f of 2 again, f of 2 again, which equal to f of 2, and the answer is letter D. The answer here is letter D. Here we have f is an odd function. F is an odd function. So since f is odd function, we can say that f of negative x equals negative f of x. It is a definition. So f of negative a equals negative f of a for every element belongs to the domain. For every element a, like this, belongs to the domain. for every element belongs to the domain. We have f of negative a equals negative f of a. So here we have the left hand side, f of a plus f of negative a equals f of a plus f of negative a, it is odd, don't forget, equals the negative f of a, and the result equals 0 here. So our choice will be letter A. Next question. We have the function f is an even over a and b over the interval a and b, then b equals, it is even function, so f of a equals negative f of a. It is an even function. Always we said we say for every negative x and the x belongs to the domain. So when x belongs to the domain, negative x must be also belongs to the domain. So we have a belongs to the domain, so b equals negative a, because if a is belongs to the domain, negative a must be belongs to the domain. Also if b belongs to the domain, also negative b must belongs to the domain also. So b equals negative a here. So this question about the definition, and we say b equals negative a. Here the curve represented in the opposite figure is symmetric about the straight line, whose equation is x equals 0, y equals 0, y equals negative 2, x equals 2. First, we must know that and remember that the equation of y-axis is x equals 0, and the equation of x-axis is y equals 0. Okay, what is the image of the point? This point, consider it 2 and 2. Its image here is 2 and negative 2. Every point belongs to the curve have another image by reflection on x-axis. Okay, how? The distance between these 2 points are equal, so you can say that for every point belongs to the curve, we have another point, it is the image by this point by reflection on x-axis. So the curve is symmetric about x dash, whose equation is y equals 0. Y equals 0. So the answer is letter B. So we can complete the curve represented in the opposite figure is symmetric about the straight line, whose equation is y equals 0. There is no steps. If f is an odd function and f of 1 equals 2, then which of the following points lies on the curve of f? As we said before, the curve of the odd function is symmetric about the origin, like this. Let us study it again. Consider this is y-axis and we have x-axis. If you want to draw an odd function like f of x equals x, this is an odd function, simple odd function. When you want to draw it, so we choose some points 0 and 0. Here is a point, 1 and 1, another point when x equals 1. So f of x equals 1, 2 and 2, also negative 1 and negative 1 here, negative 2, and so on. When you draw this curve or this straight line in this interval from negative 2 to 2, what we get? We get this line segment. We draw it in an interval here. Okay, this is an odd function. Let us study the points here. We have the point 2 and 2. 2 and 2. Its image by reflection on the origin is negative 2 and negative 2, and so on. If you have a point in odd function, this is odd function, f of x equals x. Also f of x equals x power 3 also is odd. If you have a point here negative 1 and the negative 1, its image must be exist 1 and 1. Okay, so we have 2 points here. X from the given, we have f of 1 equals 2. So from the given here we can say that 1 and 2 belongs to the curve of the function, of the given function f. So according to the definition and according to the previous discussion, since 1 and 2 belongs to the curve, so the point negative 1 and the negative 2 must belongs to the curve because it is odd function. So what is the result here? Negative 1 and 2, wrong. Negative 1 and the negative 2, yes, it is the right solution, and this is your answer. Next question. Here f of x equals x squared plus ax plus 9 is an even function. Then a equals, here f of x is even function. F of x equals x squared plus ax plus 9 is an even function. This is the given. Okay, what is the value of a which makes this function is even? From the polynomial here, if you put a equals 0, what you get when a equals 0? What you get? We have f of x equals x squared plus 9 because 0 multiply x equals 0. So the middle term not exist when a equals 0. And let us discuss this solution. When a equals 0, we have f of x equals x squared. So what is the domain? The domain of f equals r, right? Right. It means for every negative x and x belongs to the domain, we have f of x, every two elements, every two numbers belongs to the domain, we have f of negative x equals negative x square plus 9, and the negative x square equals x square plus 9, which equal f of x itself, right? So since f of negative x equals f of x, so the function f is even according to the definition. So we must choose letter C. Again, f of x equals x squared plus ax plus 9 is uneven when a equals 0. Let us discuss another number, any other number. Let us take the number here, number 3. When a equals 3, so f of x equals x squared plus 3x plus 9. Okay, so f of negative x equals negative x all square equals x square. Substituting x equals negative x, we got negative 3x plus 9. Okay, it is not equal f of x, so it is not even, right? Okay, when you take a negative here as a common factor, negative 1 actually, we have negative x squared plus 3x minus 9. It is not f of x, not equal f of x. So in this case we have f of negative x also not equal negative f of x. So what we say about the function f in this case, when a equals 3, it is otherwise neither even nor odd. Okay, so the only number which makes the function is even is 0 when a equals 0, and here is the solution. I hope you understood every step. Next question. Here we have f of x equals ax power 3 plus b is an odd function, and the curve of the function passing through the point 2 and 8. The point 2 and 8. Then a plus b square equals one of these. Okay, the function is odd and passing through the point 2 and 8, so the curve must passing through the point negative 2 and negative 8 according to the definition. So the point negative 2 and the negative 8 belongs to the curve itself. Okay, Now we have 2 and 8 belongs to the curve of the function. So we say f of 2 equals 8. F of 2 here, substituting x equals 2, equals 8a plus b. So 8a plus b equals 8. The image here, okay, as 2 power 3 equals 8, and this is 1. Also we have the point -2 and 8. So when x equals -2, we said f of -2 equals -8. So substituting x equals -2, we have -8a plus b equals -8. The required here is to find a plus b square. So first we find the value of each of a and b. You can use calculator, or you can solve it quickly by adding the two functions, the two equations. 8a plus -8a equals 0, plus b plus b equals 2b, equals 8 plus -8 equals 0. It means b equals 0 divided 2, which equal 0. Again we have 8a plus b equals 8, and the -a plus b equals -8. We say from 1 and 2, by addition we have 8a plus -8a equals 0. Okay, b plus b equals 2b, and the right hand side 8 plus -8 equals 0. So b equals 0. Substituting in 1, and we say from equation 1, what we have, substituting b equals 0, we have 8a plus 0 equals 8, and then 8a equals 0, and we can deduce that a equals 1. The required here is the value of a plus b square. So a plus b square equals 1 plus 0 square, as b equals 0 and a equals 1, so the result equals 1. And we can say that a plus b square equals 1, and the solution will be letter C. Of course, you can solve these two equations using calculator. Here equation 1 and 2, you can use calculator, okay, as follow. Here we have the calculator, and we have first mode. We want to solve two equations, so we have to press number 5, and these two equations in two variables, a and b, two variables first degree. Okay, so you press 1, and we write the coefficients. The coefficient of a here is 8. We write 8, then press equal. The coefficient of b here is 1 equal, and the absolute term is 8, equals, and we go to equation number 2, -a negative 8, it's the coefficient of the first variable, equals the coefficient of b is 1 equals negative 8. Okay, and we have x equals 1. Okay, x equals 1, it's a, the first variable, and the other is 0. Of course, you have to know how to solve it in steps and how to solve it using calculator. And the question number 11, it was the last question.